Today's lesson is on exceptions to the octet rule, 8.7 in your book. So the three questions we're going to be looking at, we want to know what types of exceptions to the octet that exist. We'd also like to know examples of each type. That'll help us when we get to a test to recognize those situations. And then we also want to learn how to use formal charge to assess these exceptions so that we can have a further understanding of why they happen. So the three types. First of all, you could have a combination of elements that gives you an odd number of valence electrons. An example of that we will see is nitrogen monoxide, which only has 11 valence electrons. We could also have something that has less than an octet. We already talked about hydrogen, helium, lithium, beryllium, things that do the duet rule. But there are also other elements like boron and aluminum that you'd like to know about. And then finally, there are some elements that go over, that exceed the octet, and those are elements that you've heard of like phosphorus, like sulfur, like chlorine. They all have the potential, when they're the central atom, to go beyond that octet. Alright, so you can see here's an example of nitrogen monoxide, and with 11 valence electrons, we have an odd number of electrons. So if you were to look at the formal charge on the nitrogen monoxide that is on the left-hand side, if you do that math, you would see that you have a 0 formal charge for the nitrogen on the left, an oxygen for the oxygen, a 0 for the oxygen next to it. Another possible arrangement then would be the nitrogen on the right-hand side with oxygen, but you'll see that the formal charges don't work out quite as well there. Because of this odd number of valence electrons, anytime you see an incomplete octets, incomplete shells like this, it's a highly reactive substance. The term that you've heard to describe these before, that you didn't know what it was, is a free radical. So free radicals have this incomplete set of valence structures, and so when CFCs go up into the atmosphere and react with ozone, they produce all sorts of free radicals that are highly reactive and do a lot of damage. Next example, we're looking at the less than 8 electrons, and we already mentioned hydrogen, helium, lithium, beryllium, boron, aluminum are other examples. Take a look at these Lewis dot structures at the top of your page and check out the formal charges that have already been assigned. Take a moment, pause, go through each one of these and decide which one is the best structure. Okay, well, looking at them, they're all pretty much the same. And there's a big problem though. We have boron in the center, which is the least electronegative. Fluorine on the outside, that is the most electronegative, yet we have a negative one assigned to boron, a positive one assigned to fluorine. We learned yesterday that that is not supposed to happen. It would be better if the opposite were true. So that leads us to this dominant form, which you see on the left. If we go through the process of finding the formal charges on this Lewis structure where boron only has 6 valence electrons, what are you going to find? Pause, figure out the formal charges on those atoms, and then continue. So hopefully you found that all the fluorine atoms have a 0 formal charge, and so does boron has a 0 formal charge, and we know that that's ideal. And so you're going to find that that is the predominant form of boron trifluoride. And so these others that have an octet are not the best way for boron to exist in boron trifluoride. Pause a moment, take the notes off the top, and then we will continue. So now we're on to the third type, which is an excess of 8 electrons. Over 8 electrons, we call these hypervalent because they've got more valence electrons than 8. And what you find is that the elements that are fairly high in electronegativity, that could be your central atom, that are also attached to highly electronegative elements like the halogens, are capable of going over this octet rule. And the picture that you see on the right-hand side shows some of the geometry, and we're going to be learning more about that geometry and how that's possible. But fluorine definitely can exceed the octet. Other elements that can exceed it: sulfur can exceed it, nitrogen could exceed it, chlorine can exceed it, bromine can exceed it. So there's lots of things that can go past. Actually, I'm going to take nitrogen off that list. It should not be. Taking a look at the formal charge. And again, here's that same comparison we did with the boron trifluoride. The Lewis dot structure on the left-hand side has the correct number of electrons in terms of octets. Everything there has an octet. We see that the formal charge numbers, phosphorus is a +1, oxygen is a -1, and that makes sense. That's acceptable. We also find, though, that perhaps this structure is a little bit improved if we add a double bond with the phosphorus in one of the oxygens. Now we have 2 zeros for formal charges and the other -1, which are in an appropriate spot. So phosphate might not necessarily just be the octet, might not just be following the octet rule. It might exceed the octet and be hypervalent. Pause a moment, take these notes, and then we'll continue. So in summary, there are 3 types of exceptions to the octet rule. Can you name them? Hopefully you came up with odd number valence electrons, less than an octet, and hypervalent, which means more than an octet. You should know some exceptions to each type. That can be helpful. Your book has more examples, so you could go into the section 8.7 and find that. But let's say, for instance, we could know nitrogen monoxide as an example of the first type. We could know boron trifluoride as an example of less than an octet. And we can know that phosphate goes over an octet. Another one for that you could know is sulfate. And the hopefully last thing that you learned is that through formal charge assessment, we can figure out or justify why these exceptions can happen. So if you have any questions, let me know. Otherwise, we are one section away from being done, 8.8. Enjoy your day.